All right, so a major part of chapter 5 is dealing with sequences. Which we classify as an ordered set of a list of numbers. Technically, it doesn't have to be numbers, but it's a math class, so it's going to be numbers. So a sequence will look like this. And we got our first term, second term, third term, fourth term, so on and so forth. And you got 3 dots. Indicates that the list continues. Okay, we'll mostly be working with 3 different types of sequences. Well, there are 3 types. We're really going to focus on 2 of them. First one's called arithmetic. Where we're adding or subtracting, it's the same thing. Between each term. Alright, so we have 1, 5, 9, 13. We're adding 4 between each term. So that'd be considered arithmetic. Next one, geometric. And we're going to be multiplying or dividing, but really we're going to be focused on adding and multiplying when it comes to our equations. Okay, multiplying between each term, multiplying by the same number between each term. And so this example, 3, 9, 27, 81, and we're multiplying by 3 in between each term. And the last one, we don't focus on too much, but neither or are there if it doesn't qualify as one of those. Okay, so if it's not adding and multiplying by the same number between each term, then it falls into that category. So this sequence here, Fibonacci sequence, where basically you're taking two previous numbers, adding them together to get your next term. So 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8, 13. Fairly popular sequence, but it's not arithmetic or geometric because you're not adding or multiplying by the same number each time. Okay, so the equations for these sequences are different, but at least the arithmetic ones very similar to a linear equation. So for arithmetic, our equation is T of n equals dn plus c. Where d is what we call our generator. What are we adding? And C is going to be our zeroth term. Okay, we'll go over what those look like here in a second. Geometric sequence. A bunch of new letters too, but they mean the same thing. Case of zeros are zeroth term, and R is our generator. Again, what are we multiplying by? Okay, if it's an either or another, then they don't have equations. They're usually pretty random. Okay, so you notice T of n, obviously it's a little different than using y or f of x. Okay, usually we use T of n to represent sequences. Okay, it's just what we use. Okay, but they mean essentially the same thing. If you take a look at dn plus c, it's very similar to y equals mx plus b. Okay, what are we adding each time and where do we start? Right, our zero terms, where are we starting? What are we adding each time? Arithmetic, very similar to a linear equation, y equals mx plus b. Geometric, okay, we haven't dealt a lot with exponents, okay, but if you take up the exponential equation, y equals a times b to dx, okay, again, it kind of is the same thing where a is your starting value, okay, and b is your multiplier, whatever you're multiplying by each time. Okay, so again, your zero term goes first. Okay, whatever we're multiplying by each time is our r value. Okay, just raising it to the nth power. Okay, so let's take a look at an example. Of a sequence, some of the types of questions will be asked. Okay, so here we have -4, -1, 2, 5. So first thing we have to identify, is it arithmetic or geometric? So identify, are you adding or multiplying between each term? Okay, hopefully you're able to recognize, okay, we are adding 3. So this sequence is arithmetic. Okay, so we got to write the equation. Reference our previous page, and we understand it's got to be in the form T of n equals dn plus c. So we need two things. We need our generator, and we need our zero term. Okay, so our generator is just going to be, what are we adding each time? Okay, we identified it earlier, we are adding 3. Pretty straightforward. our 0th term. Okay, so remember, this is our first term, second term, third term, fourth term. So this is our first term. We want to have to kind of go backwards and identify, okay, what would happen before -4? And if we're adding 3 going this way, okay, what are we doing going this way? Should be subtracting 3. So -4 minus 3 would give us a 0 term of -7. Put it all together. We get an equation that is t of n equals 3n minus 7. Okay, so now maybe we might get asked a question like this. Okay, and this is where the equation comes in handy, because if we're asked to find the 50th term, or the 100th term, or the 1000th term, okay, 2 ways we can do it. One way would be to keep writing out the sequence, right? -1, 2, 5, 8, 11, 14, 17, 20, 23, 26, and we can keep going. That would probably take a while, though. If we want to find the 50th term, okay, that's what this n represents, the term number. So we can just take 50 and plug it in for n. So t of 50 equals 3 times 50 minus 7. 150 now minus 7. So we now know the 50th term is 143. A lot easier than having to count everything out. Now, worst case scenario, you're taking the SATs, you're taking a test, whatever. Can't think of it? Yeah, you could write out 50 terms. You could also write out 50 terms and try and check your work. Ask for the 500th term. Yeah, it'd be kind of tough. Take you a while. Hope you don't screw up along the way. Okay, you might also get asked, is 127 a part of the sequence? Okay, so different question than number 3. Essentially, we're being asked to plug in 50 and get the answer. Here, you're being asked, is this a possible answer? So we're going to plug that in for t of n now. So we're going to say 127 equals 3n minus 7. Add 7 to both sides, we get 134 equals 3n. divide by 3, and we get n equals 44.67. So do we think that number is part of the sequence? Yes, no, maybe? Anybody brave enough to use their voice? No, why not? Because it's not 127? Why not, Will? Because it's got a remainder or it's got a decimal? Okay, so whenever we're doing this, it has to be a whole number. Okay, and the reason it is because in sequences we only have the first term, the second term, third term. We don't have a 44 and 2/3 term. All right, that doesn't make any sense. So unless this is a whole number, then it is not part of the sequence. All right, and that kind of ties into what the graph looks like. If we were going to graph this sequence, our first term is at -4. Second term is at -1, 2, 5, 8, so on and so forth. Okay, notice I'm just plotting the points. Okay, we talked about this before we left for break. Okay, but whenever we're not connecting the points, that is called a discrete graph. Okay, well, we're not going to connect the points. Okay, and again, that's because there's not a half of a term, there's not a 3 3/4 term. We're only dealing with whole numbers. So we'll take a look at some examples. Have you tried this one on your own to start here? You get a sequence of -7, -1, 5, 11. Identify if it's arithmetic or geometric. And then also find the 40th term. Okay, so not too bad going around, taking a look. We go from -7 to -1, -1 to 5, 5 to 11. Hopefully we identify that we're adding 6 each time, which makes it arithmetic. So our equation, we need our multiplier, or I'm sorry, our generator, and our zero term. Our generator we identified as 6. Zero term would be what would come before -7. And in this case, makes that -13. -7, we have to subtract 6 to go back 1. So our equation, T of n equals 6n minus 13. So then find T of 40, the 40th term. Plug in 40 for n. Get 240 minus 13. So we should get 227 as our 40th term there. Okay, see type of deal here. Got a sequence. Identify if it is arithmetic or geometric. Find the equation. And then find the 11th term. Everyone's kind of confused on the same part, which is fine. Just means I'm a bad teacher. Okay? So we all identify that we're multiplying by 2, right? We've all kind of gotten that far. Okay, so it's going to be a geometric function. So the equation I gave you, T of n equals a sub 0 times r raised to the nth power. Okay, so a of 0, okay, that whole symbol itself just means 0th term. It's just a fancy way of saying what is your 0th term. So it's an a with a subset of 0, okay, but just identify it as the 0th term. So, working backwards, if we're multiplying by 2 going to the right, what are we doing going to the left? Should be dividing by 2, right? So what's 2 divided by 2? 1. Okay, our multiplier, we've already identified our generator as 2, raised to the nth power. So that'd be our equation. And again, it's raised to the nth power. So when you're asked to find the 11th term, Okay, I'm seeing a lot of people give me an answer of 22. But that is incorrect. It's 2 to the 11th power. So 2 to the 11th power, 2048. Or 1 times 2. Okay. So even if you're confused or you're not sure if you did something wrong, right? If you got an answer of 22, if you go back and look at your sequence, okay, if I kept going, my next number would be 32. I already skipped over 22, and that would have been in between my 4th and my 5th term. All right, you could keep going, blah, blah, blah. Okay, so you can always kind of, does 2048 look like it's going to fit? Yeah, probably. Okay, have you tried a couple more here on your own? All right, so first one, a little bit different here because we are not adding 3, but we are subtracting 3 to go from one term to the next. Okay, still arithmetic. Okay, our D value is -3. Our C value, okay, what number would come before 12? 15. So we get T of n equals -3n plus 15. Okay, since we're subtracting, our generator has to be -3. Really, it's for adding a -3. To find the 100th term, T of 100 equals -3 times 100 plus 15. So we get -300 plus 15. So -300 plus 15 equals -285. Second one, we go from 1 to 5 to 25. Okay, we're multiplying by 5 each time. So it's geometric. And remember, T of n equals a sub 0 times r raised to the nth power. Okay, our generator, our R value, we've already found is 5. Our 0th term, okay, we have to work backwards. Instead of multiplying by 5 going this way, we've got to divide by 5 going this way. So 1 divided by 5, 1/5, okay, or 0.2. I think it's easier just to use the fraction. So our equation, T of n equals 1/5 times 5 to the nth power. Seriously not plug that in? You didn't plug it in when you put it back? So to find the seventh term, t of 7 equals 1/5 times 5 raised to the 7th power. Okay, so we got to be careful on this. Okay, member of PEDMOS, please excuse my dear Aunt Sally. Okay, do we multiply these first or do we use the exponents first? Exponents. Okay, so if you're putting it on your calculator, it might on your phone, it might not do it. If you use a calculator like this, it'll do it fine for you. But if not, 5 to the 7th times 1/5 gives you the same thing. Okay, 1565 or 15,625.